Sure. Thank you very much. Okay, so what we're here to talk about tonight is this concept of immutable infrastructure. So what I'm going to try and do, and I'm going to attempt it, is to illustrate what that is in concept, and then show some practical examples of how we can achieve that using a couple of software applications that help us do that. So the first thing I wanted to point out is if you are interested, all the slides that I'm currently showing are available on that short link there, and all the code for what there is available on my GitHub repository, and that's linked via that link there. So if you are interested in that, feel free to grab it. So I guess where we need to start is to define what is immutable infrastructure. A reasonably lengthy definition suggests that an immutable infrastructure is another infrastructure paradigm in which servers are never modified. If something needs to be updated, fixed, or modified in any way, the servers are built again. So rather than continually editing something and potentially getting it into a state where you don't actually know what's on that server anymore, you build that infrastructure from a known good location. Okay? After they've been validated, they can put into use, and the old ones are kind of just circled out. You don't use them anymore. You take them out of the load balancer, you take them out of whatever setup you've got, but you're always creating that infrastructure from a fresh known entity. And that known entity can be regenerated as things change, but then that one entity is then validated again and then put into deployment, whatever that is. Okay? So this brings into the concept. There's this kind of well-known pets versus cattle, and this comes from someone called Randy Bias, and there's a link there to a blog post where he goes into it in more detail. But the concept is that if you treat your servers like pets, for example, Bob the mail server, if that server goes away or Bill gets ill, then everything's broken. And you have to kind of rustle around trying to put those things back together. If instead you have this concept of a cattle mentality for your servers, then you don't individually name them. You don't call them Bob. You call them Web Server 1 or Web Server 2. And if one of those things breaks or changes, it's quite easy to change them out. Some people don't like the pets versus cattle because of its connotations. So it's also known sometimes as Snowflake servers or Phoenix servers. So a Snowflake server is a server that's managed by hand, frequently updated, and tweaked in place. So you've got a server, it's doing something, and you continually modify that to get it to do what you want. But again, you get into the cycle of you end up not knowing what that server is actually doing anymore. Whereas a Phoenix server are the cattle. They're the ones that are built from scratch, and they're easy to recreate and rise from the ashes, if it were, hence the Phoenix. And the idea being that you have automated process in place to allow you to provision those where you need them. Okay? So having spoken about that, the next question that comes up is really, well, what's the benefits of immutable infrastructure? Why would I do this? Why would I go to the hassle of re-provisioning something if I've already got something in play? So the first couple of things there are the idea of fewer deployment failures. If you've got a known entity that you're taking and putting somewhere, then 9 times out of 10 it's just going to work. Whereas if you're taking something and then manually going through some sort of process or even an automated process to get to a known state, things could go wrong. Whereas if you've got something that's already known to be good, then all you're doing is deploying it. Okay? There's also the concept of configuration drift, and there being no configuration drift when you've got immutable infrastructure. There, again, it's that concept of someone logging on the server, making a couple of changes, and then either not documenting it or not forgetting about it to then not be able to get back to that state again. Now, there are systems in place, configuration management systems, that will help alleviate that, but again, with the concept of immutable infrastructure, where you are deploying those from a known entity, you don't have to worry about that. Consistent staging environment, so again, it's just that concept of getting to a known point in time and going re-provisioning when it's needed. And also there's the concept of a simple rollback. If you do a deployment, you haven't really, that other one's not gone away yet, you can always fall back to it. What you're trying to do is replace it, test that it's good, and then remove it out of the pool. So there's a simple rollback and just you go back to the old server. So with all of that said, where I'm going to start the discussion is not with immutable infrastructure. And there's good reason for it, and we'll come back to why that is. But what I'm going to talk about first is a software application known as Vagrant. So Vagrant, what is Vagrant? Vagrant is a tool for provisioning and managing virtual machine environments in a single workflow. Now, so Vagrant is a software application from a company known as HashiCorp, and it's essentially that. It's a mechanism to take a base box, so you can have multiple base boxes set up in Vagrant, and you can literally say Vagrant up to provision a new instance of that VM. And through the provisioners that Vagrant provides, you're capable of bringing that machine up to a known state. But again, it's still kind of regarded as a snowflake in the sense that you are running that as part of your provisioning, as opposed to just provisioning something that's already been created. So an example Vagrant file, when you start thinking about using Vagrant, you have this concept of a Vagrant file, and it's it that will define how that VM is going to be provisioned. So if we look at what's in here, you kind of have to define a known starting point. So in my case, for this example Vagrant file, my starting point is going to be a box, the Stefan Sharer Windows 10 box, that's freely available on the internet. So Stefan, I know him, I've met him, he's a really nice guy. He works very, very hard to maintain that Windows 10 base box image so that other people can use it. So every few months when Microsoft releases a new version of the base operating system, Stefan has some automated processes that go through and creates that VM and makes it available on this thing called the Vagrant Cloud. So if you're interested in using it, you just download it, and then you can provision your VMs from there. Having defined that that's going to be my base box, what you've then got within your Vagrant file is the ability to alter that VM, how much RAM you want to give it, how much CPUs you want to give it, whether you want to connect audio, clipboard, all of these things. All of these things can be set up based on your configuration within this Vagrant file. And then what we've got, if I can scroll over a bit, is we have this concept of, I mentioned that Vagrant has this concept of provisioners. So within my Vagrant file, I can say I want to do these things. So in my system here, I'm just shelling out to do some PowerShell work. Okay, but you could be shelling out to any of the other provisioners that Vagrant provides. Okay, so what I'm going to do is I'm going to go in here. So this is just a terminal session to my repo that I've cloned. So the repo that I mentioned is over here. I'm going to get rid of this so we don't get inception. So this is my repository on GitHub, and in here I have a Vagrant file, and that Vagrant file is kind of just the one that I've showed you just now. So this is the full-blown Vagrant file with all its bells and whistles, and what I've got in my terminal session here is that Vagrant file. So I can just go here and go Vagrant up, if I can type it. So what that's going to do is it's going to run through those provisioners, and it's going to make sure that that box is in the state that I want it to be. Now, I've cheated a little bit in the sense that I've already provisioned that VM ahead of time, because there's no point in you sitting watching it, because all it's going to do, if we go back to here, if we go back to the Vagrant file that I had here, then what it's doing is it's running 4 or 5 PowerShell scripts that I have in this folder. So one of those is to install Chocolatey. So full disclosure, I work for Chocolatey, so I'm a bit biased towards it, but in terms of installing applications onto a machine, Chocolatey does a very good job at that. So I've got a PowerShell script here that is simply installing and configuring Chocolatey, and then what I'm asking it to do within one of these other PowerShell scripts is to install required applications. So onto this Vagrant box, I'm going to install .NET 4.7.2, VS Code, a bunch of VS Code plugins, and then I'm going to install Packer and Terraform, which are the 2 applications that we're going to eventually talk about. But all of that takes a little bit of time, and I didn't want to waste your time showing you that. But the end result is I then have a VM instance that has all of those things in it. So it's already got VS Code on it. Let's go up a level, and we'll just open VS Code. So VS Code is installed on the machine, ready to be used. Okay, so it's done what I asked it to do. It's created that VM instance, and it's set up everything that I wanted it to. Now, it's done that in a way that if someone else wanted to use this machine, they would have to run through that provisioning step as well. So if you needed to provision this onto 100 desktops, then 100 people have to run through that same installation code. Okay, so that's kind of where the concept of immutable infrastructure starts and stops, is that with Vagrant, you are doing that work when you need it. Okay, so that's the kind of the distinction between Vagrant and what we're going to start using, which is Packer. Okay, this was an experiment. I'll explain what this is. Using this system called ASCII Cinema, or ASCII Inema, I can record my terminal sessions, and the idea was that I was going to show you all of the output that you get from a Vagrant up, but it's almost minuscule. You can't see it, so it's useless. If you are looking at the slides back later, you'll be able to see what it's doing, but it's literally the recording of the entire session, so it will show you what you can expect from the Vagrant up command. Okay. So the next question that we want to look at is, what is Packer? Okay, so Packer is an open source tool for creating identical machine images for multiple platforms from a single source configuration. So that kind of it's different from Vagrant because it spoke about a single workflow and provisioning a VM in a single workflow. Whereas Packer, what we're saying here is it's a tool for creating identical machine images for multiple platforms with a single source configuration. So it's multiplying out in terms of what you can do. So this tool is also from HashiCorp. HashiCorp have a range of tools in this area. Vagrant and Packer are two of them. So what does that mean? Well, again, we have this concept of a single file that drives that Packer tool. Okay, it's not the same format. So before we had a Vagrant file that had its own kind of layout and how it works. Packer works with a JSON file. So everything is in it is defined in JSON. So what we kind of have here, this is just a really, really simple Packer file, is we have this section of variables. So in order to utilize Packer, you're going to run it against something. Now in my example here, I'm running against AWS, so the Amazon ecosystem for provisioning a VM or provisioning whatever infrastructure that you want to run in AWS. So you need to give it some variables so it can connect and do the work on your behalf. It's all about automating the process of creating and provisioning those VMs, or creating those VMs rather. So you need to define those variables. Then you have this concept of a builder. So in my scenario here, what I'm saying is I want to build a VM instance and then provision that as an AMI in AWS. So what that means is that becomes a Amazon machine image, I think is what it's referring to. So it's something that you can then create a VM from. It's not actually creating a VM, although it does do that during the process. But the end result is something that you can use to provision a VM from. Okay? So we define that we're doing that in AWS with the Amazon EBS type builder. And then from there, again, we have this concept of provisioners. So this concept is exactly the same that we saw in Vagrant, that we want to do stuff. So in this scenario, all I've got is a very simple, this is taken directly from the introduction tutorial that you would go through on the Packer website. So literally all it's doing is it's running some inline PowerShell that just shows how you can escape quotes and single ticks to make it work in the way you expect it to. So it actually doesn't do anything, but it just shows what will happen. And there's another one there that's just running another PowerShell script, again, just to show how things are escaped. So if we jump to here and go into the demo folder of demo 1, what we've got in here is, that's the wrong one, so we're going up to demo 2 now. In here, we've got that JSON file, which is my first run JSON file. So what we're going to do is I'm going to do Packer validate first of all. So the Packer validate command will validate that the JSON that I've put into that file is valid. Okay, so if you've used an environment variable or use a variable that you haven't defined, then the validate will ensure that that's correct. Okay, so it's a compilation step effectively. It's you verifying that that JSON file is correct. So if we go here and instead we run the Packer build command against that first run JSON, then it's going to run off and start doing stuff, and it's going to be almost illegible on the white screen, okay? But what's happening there, if we start looking at what's going on, then over here in my AWS account, what we'll see is that Packer is doing something. It's taken that base AMI image that I've told it about, and it's provisioning an instance of that VM, okay? And then it's going to execute those inline commands. So either, I had two provisioners. I had one inline PowerShell and one just a PowerShell script. It's then going to run those on that machine, and then it's going to shut that machine down, and then it's going to take that and make an AMI out of it, okay? So the AMIs live over here. So currently I've got nothing in this window. I have no AMI instances. But when that Packer build finishes, it's going to take what's in here in the instances folder and move it over into the AMI images folder, okay? So it's quite boring. We're not actually doing anything yet. All we've literally done is said, take this base AMI image, run some scripts on it, and then stick it over here into my account. So we haven't actually installed anything, we haven't configured anything, but this is just showing, it's like the bare minimum that we can do to kind of show how Packer is actually working. So when this actually finishes, so right now it's kind of stuck at waiting for WinRM. Anyone played with WinRM before? Know what it is? Love it? Hate it? Great. Right. So WinRM is kind of the way that you can connect to a remote machine and execute commands on it. Okay, and this, what's happening here is it's essentially stalled, waiting for that image to boot up, for WinRM to start, and then at that point, Packer will be able to communicate with it and do stuff on that machine. So it's kind of the, I want to say the good and the bad thing about trying to do this in Windows world. Things are a little bit slower because you have to boot up a VM with Windows on it, you have to go into the operating system, you have to wait for WinRM, you have to wait for all the things to line up before you can actually do anything. But eventually it will finish. But we're not going to sit here and wait for that. I'm just going to let that happen in the background because we're going to move on to the next demo, unless there are any questions about that. Like I say, feel free to ask any questions about any of this as we're going through it. So we go back to the slide deck. That's the demo on how to generate the AMI, and that's that one. Okay, so Packer is, if we think back to what the definition of what Packer was, there's this concept of provisioning or running against multiple locations at the same time. So Packer's really clever in the sense that it will do a lot of that in parallel. So rather than sitting waiting on something, if it can, it'll go off and do something else. So in this example file, we've got the same AWS variables that we had before. But what we've got instead, where is it? Where's what I wanted to show? That's not showing up properly, so I'll maybe just jump to the file instead. Where's VS Code? VS Code's here. In this one, it's slightly different. That's obviously not pointing at the right file. What I'm trying to show here is that I want to go both to Amazon to do something, but I also want to go to this other place. So this do is DigitalOcean. Anyone heard of DigitalOcean? So there's lots of places on the internet where you can do this work. There's obviously Azure, there's AWS, there's the Google Cloud Compute, there's DigitalOcean. All of these things you can do creation of VMs and the running of VMs as you need to. So in this example, I am going to attempt to provision both a VM to Amazon and to DigitalOcean. Okay? And I'm going to do that using the builder. So there's a specific builder here for doing that against Amazon. And then this is very similar to what we had before. But the only difference now is that I've got an extra type here, which is for DigitalOcean. So I'm going to create, while I'm creating one in AWS, I'm also going to create one in DigitalOcean. And what we're going to do, so this is where things are going to get a little bit scary in my mind, right? I'm a Windows guy, although I've got a Mac. I'm going to attempt to provision a Linux machine in AWS and DigitalOcean, and onto that machine, I'm going to install a Redis server. So we're actually going to do something on these machines this time around. So in here again, you could put any provisioners that you wanted. I'm going to attempt to install Redis, right? So to make things a little bit harder, because why not? So the demo that I did before, and it's getting there. So this demo that I was running before has, it's now created that, it's run that instance, and now it's stopping it. So if we go back to AWS just to see what it's getting to, so if we go back over here, we now see it's stopping that instance because it's finished with it. It's run our scripts and it's run the provisioning steps, and now it's going to throw that away. It's essentially going to tear it down, okay? So what I did was, this is me running in terminal on my Mac, provisioning a Windows machine. So let's go over to this Vagrant machine that I created before, which is Windows, and we'll use that to provision a Linux machine. We'll just kind of flip it on its head. This is mainly to show the kind of the flexibility of Packer, and you can run it from a single source on any machine, okay? So let's just try and make this a little bit bigger so we can see what's going on. And let's go into the demo folder, and we're at demo 3 this time, I think. Nope, we've gone too high. CD. Oh, I know where that is. That's my fault. I'm on demo 2 on my Linux, on my Mac, but I haven't pulled the latest source code for this particular thing down because I changed the demos around. So I'm still on demo 2 here. So demo 2 is my parallel build. So over here, I'm going to do a Packer validate. You guys see that okay? Maybe bigger. Properties, make it bigger again. Let's go up to 24 here too. A bear. Let's pull this up. So I'll do Packer validate again on my first run JSON just to make sure that it's got everything I need to. And then I'm going to do the Packer build command against that first run JSON. And what we should see in the output straight away is it's doing something to DigitalOcean and it's doing something to the Amazon EBS. So straight away, Packer's working in tandem. So if we jump back over here, what we should see in our instances, that one's now stopped. We've now got another one running up. So this top one is our Windows instance that's in the process of being terminated by the first Packer execution. This one is creating a Linux VM in Amazon. But it's also, once it's provisioned, it's going to install the Redis server onto that machine. And if we go over to here into our DigitalOcean website, we'll see that it's currently provisioning a droplet. So there's different terminology across different providers. So in Amazon, we talk about an instance. In DigitalOcean, we talk about a droplet. So what it's going to do is it's the exact same thing. It's going to create that droplet. It's going to install Redis onto it. And then what it's going to do is going to save that as a image once everything's finished. Okay? So if we jump back to that one that was provisioning the Windows machine is still going. And over here, what we should find is that this one might actually finish before the Windows one's finished, okay? It's just the way things are, right? Linux is obviously a much smaller footprint operating system. It's quicker to spin it up, and things are just quicker, okay? Just depending on how you're wanting to work with Packer or Terraform eventually, and what your endpoint is, it'll either be really quick, or you might be sitting waiting at a terminal to see what happened. Okay, so in this one, the Windows one has actually finished now, okay? So that's still running, but if we go back to our Amazon console, which is over here, what we should see now, if we refresh this, is that that first one's actually terminated. So it's gone. As far as AWS is concerned, that's not costing me anything anymore. It's terminated. It's still sitting in that window because you get a little bit of a cache, effectively, of it tidying up after itself. But what we should have now over in my AMI section is we have this AMI ready to be provisioned. Okay? And eventually, once that second Packer instance is completed, this one will be marked as terminated. It's catching up. So this one will be marked as terminated, and then over in my AMIs, I will have 2 AMI instances ready to be used. Let's bring that down a bit. And if we go over to DigitalOcean, see where it's getting to, then the droplet's gone. So it means that that instance has gone. And now over here in my images, I have a machine provisioned in the cloud that will have Redis on it. So if I wanted to take that machine and provision Redis across my environment, I've then got an image that has that on it. I don't have to install it and bring it up to a known point. I've already got that known point ready for provision. Everything make sense so far? Good. Okay. We're not too bad. Right, back to slides. So, the next one that I want to talk about is something that I make use of. We have the concept of what we've spoken about so far is utilizing some of the cloud provisioning systems to take a base VM, do some work, and then have something output. This example is slightly different in the sense that I'm going to use a local machine. So Packer, in the same way that I can go off to Amazon and Azure and DigitalOcean and use the VMs from there, it can also use things local to your own machine. Okay, so in this example, what I'm saying is I want to configure a bunch of things called floppy files. So when you're provisioning in this way, there's still the concept of a floppy disk. So that's you putting files into the VM to actually have some stuff happen. So in this one, what I'm saying is I want to use a local ISO that I have on my machine. And from that ISO, I want to spin up and then do a bunch of stuff. So that stuff is going to be similar to what we did in my first Vagrant example. It's going to be installing Chocolatey. It's going to be provisioning some applications onto that machine. It's going to be running Windows updates. It's going to be compacting the hard drive so that it's nice and flat and it's not occupying any more space than it needs to. And then what we're going to do is this concept of a post processor. Now, we didn't need to use this when we were provisioning into AWS and DigitalOcean, but in this one, I've got a post provisioner that says I want it to output a new Vagrant image. And I want to use this Vagrant file template as how that Vagrant file is going to be, or that Vagrant box instance is going to be made up. And again, we've got the concept of variables. So in the same way that we had variables for my AWS keys, I've also got the concept of where I can get those ISO file from and the checksum for validation and all that sort of stuff. So again, I want to show a demo of this, but what I've just described, so let's go over here and have a look at it. So in this demo, which is demo 4, these are all the files that I'm using to make up that thing. So if we look at the Windows 10 JSON, then it's suddenly got a little bit more complicated. So we've gone from a fairly small file that's just taking an existing VM instance in the cloud, or a VM image in the cloud, doing one or two things, to this thing, this monstrosity of a JSON file that's now doing a bunch of other stuff. So up here, we've got things like disable screensaver, disable WinRM, enable WinRM, run Microsoft updates, run Windows updates, and then further down, so those are all the things that would happen as the actual machine ISO is booting, okay? Now, the reason that you would want to do that is, we'll go into that in a bit. But further down here, we've got a bunch of provisioners that are doing other things, and things like enabling RDP, things like debloating Windows. So it's running a tool on Windows itself once all the files have been installed to compact the file system, essentially defrag it, get it to a fresh known state. And then we've got things like setting power plans, disabling Windows Defender, because in an environment you might not want it or need it. So in my machine, I'm doing that. I've then got installing a Chocolatey and installing required applications. And then I've got a bunch of stuff down here for enabling UAC, compacting again the hard drive, compiling .NET assemblies, lots of stuff that if you had to do on a machine multiple times over and over and over again, it starts lending itself more towards that Snowflake server, which we're trying to avoid. So by doing all of these things up front and getting to a known machine instance that you can then test and verify, you can then deploy that out to everyone that needs it. So I said before in the first example that provisioning a Vagrant instance and doing that stuff took a long time. This takes a long time too. So I'm not going to do this in here, but if you are interested, it would literally be a Packer build of that Windows 10 JSON file. And the output of that is this, where did that go? The output of that is this Windows 10 Virtualbox box. So it's about a, I want to say like 8 gigabyte file that is literally everything I've just described. It is a base Windows 10 ISO, automatically installed, so there's an unattended, an auto-unattend XML file that steps through the manual steps you would otherwise have to go through for choosing what keyboard layout you want to use, all that sort of stuff. And it's doing all of those things, and the output of that is this Virtualbox box that we can then use and have all of those things already installed on it. Okay? Make sense? It's quite boring to watch it, but you kind of have to watch it at least once to see the magic of what it's actually doing. So I would invite you to run that if you get a chance. So, having done all of that, we're now in a position, potentially, where we can start thinking about taking these base images and doing something with them. So that's where this other tool from HashiCorp comes in, which is Terraform. So Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. So that doesn't really describe the sheer awesomeness of what Terraform is, but essentially what we're talking about there is Terraform is a level above, if you like, all of the cloud provisioners and the hypervisors that you would get on multiple machines. So when I'm talking about hypervisors, I'm talking about Virtualbox or VMware or, try to think of another one, and it's escaped me just now. So it sits above that. And it can talk to all of those systems. So again, from one file and one tool, you can communicate to provision an instance into AWS, but also into Azure, and also into DigitalOcean, and also into Virtualbox, and all of these systems for controlling all of your hardware requirements. So I'm talking about things like controlling your load balancers, your web servers. Any piece of infrastructure you can almost certainly control through Terraform. So there's a growing number of providers on the website that you can use in Terraform. Okay. So in Terraform, again, so this is an example Terraform file. It's slightly different again. So we've gone from a single Vagrant file for controlling our Vagrant boxes to a JSON file for using Packer to another one that has a TF extension. So all Terraform files end in TF. And you can split those files up into individual files to make it easier to understand what's going on. But ultimately what will happen is that Terraform will take all of those together at the time of building and put everything together. So in this example, I'm showing a variables file. So in this variables file, again, I've said, here's my Amazon AWS keys. Now they are actually, under the hood, they are environment variables on my machine, but what I'm saying here is just the name of those files and the name of those variables that I can bring them into my Terraform execution. So again, as an example, this is kind of the easiest example that I can show of what Terraform does. What this Terraform file is going to do is it's going to take that base AMI that we created in demo 1, which was our Windows instance, and it's going to provision an instance of that in AWS. So in order to do that, I need to tell it, these are my Amazon access keys. This is what I want to do. So I want to take this thing, which is the name of the base AMI, and I want to create an instance of that as a T2 micro, because I'm a cheapo. So it's like the lowest of the low. It's like 1 gigabyte of memory and however much hard drive space, but it's cheap, and we're not actually going to do anything with it. So what we're going to do here is we're just going to echo out the IP address that's been assigned to that VM, just to see how it's being provisioned. Okay, so that's just going to happen on the box itself, and it's going to be output on the console command line. Because the way I'm doing this is I'm actually using an elastic IP that one of the things that AWS provides, and then I can also take that as an output variable. So you can hopefully see that within Terraform you have these concepts of output variables that you can then pass on to another piece of provisioning. So if you wanted to spin up a VM and then know what the IP address was to then connect another machine to it, then this is how you can start stitching all these things together. Okay? So let's go over to AWS just to make sure that everything is the way we want it to be. So over in AWS, we should have 2 instances that are terminated, because those are dead now. We're not using them anymore. They were just there for the creation of our AMIs. So they're terminated. Eventually they'll go away. They'll drop out. But over in our AMI section, we should have 2. So the first one is the I'm going to look at the date to make sure I get the right one. So this was the first one. So this is our Windows instance, and this is our Linux instance that has, or Linux image, sorry, that has Redis on it. So we could provision that one, but what I'm going to provision is this one. Okay? So I'm going to do that by going over to here. Let's use Windows, because it might actually be easier to read than that currently. So let's go up to the fourth demo. So in here, I've got my 2 Terraform files. Okay? So the command that I'm going to run here is Terraform apply. So what that's going to do is not work. Let's go over to here and let's do that again. Let's not worry about what's going on there. Let's do Terraform apply. I know why that is actually, because I've not actually done what I needed to do, but let's do this. So prior to this, in order to kind of set up a provisioning folder, you have to run the Terraform init command. So what actually happens there is that the Terraform exe will reach out to the internet to download all the provisioners that it needs in order to execute the commands you've asked it to. So it'll look at the Terraform files and it'll say, you need the AWS provider, or you need the DigitalOcean provider, and it'll download all of those into a hidden folder that you can't actually see there. I've done that on my Mac, I haven't done that on the Windows machine. So I'm not cheating, I promise. Okay. So if I do Terraform apply here, it will look at that and it will say, this is what's going to happen. It will say, this is the Elastic IP address, the Elastic IP resource that it's going to create. This is the AWS instance that it will create. And these are all the things that it will do for me. Now, I've just realized, because no one's pointed out, feel free to speak up, this doesn't actually exist. So this is the AMI instance that I did in my demo before I came to here. So I'm going to need to grab the actual AMI instance that I want to, AMI image that I want to use. I'm just going to kill that. So if I go back over to AWS console and I click on this one, then this is the AMI ID that I want to use. I'm going to copy that and I'm going to go back into Visual Studio Code and I'm going to go into my variables, no, not my variables, my example, and I'm going to delete this one. So I don't want to use that one. I want to use the one that's on my clipboard, which is that one. Okay?
So can you give them link
So in this example, what you would probably actually do is you would combine your Packer execution and your Terraform execution. So the actual provisioning of that would flow into it. So in this example, I've done them as disconnected, just kind of to illustrate the point. But you could absolutely do it so that those things were known about. Or they become variables that are then environment variables. So you could define them as environment variables on wherever you're doing the provisioning to then have that as the base image. Because again, in a immutable infrastructure, that base image probably isn't going to change that often. But the provisioning might happen multiple times as and when required. So in this example, I've a manual step to do that, but you could almost certainly automate that, absolutely. So now that I've got the right API instance, if I run that command again, it'll print out what it's going to do. And if I just type yes, it'll start running off and doing all of those things. So again, if we go over to our AWS console, what we should see is there's another instance being created here. And this instance won't be terminated at the end of the execution, because this is us actually saying we want this provisioned into our infrastructure. So this is only doing the provisioning of one machine, but you could imagine that this is actually doing however many, X amount of provisioning. You could spin up as many of these as you wanted. Within both AWS and Azure, you can then have the concept of network topology. So you could have certain machines all collected together on one virtual LAN, another set of machines on another virtual LAN for isolation. All of these things are up for debate because they're just resources within your Terraform file. Yeah. So what we've now got is a running instance of that AMI that we provisioned with Packer the first time around. So if we go back over here to our output, we should see an IP address. That IP address there I should then be able to copy this, and I should be able to go into here and connect to it. This is off script a little bit. I didn't actually test this part, but in theory, if it's spun up and it's at the point that it can accept a connection, that would allow me to connect to that box, okay? It may still be thinking about it. Let's go back over here. It's still saying initializing, so it's maybe not quite ready. And I've got an annoying little Windows pop-up here saying that it's failed. But we'll come back to that and test that later. But hopefully, again, we're illustrating the point that Terraform, in the same way that Packer is that level above those kind of lower level concerns. With a simple file, you can control instances and create instances in all of these architectures. Okay? So we'll come back to that, just to close that out. Oh, no, okay. Let's try connecting one more time, because what I wanted to show next is destroying it all, right? Because that's the other good thing about Terraform, is that it does, although it's can be used in the concept of immutable infrastructure, it can also be used to continue to make modifications to an existing instance. So if you change something, or you want to re-provision something, you can use Terraform to apply those changes to it. And that's what it was talking about in the description, where it was talking about versioned infrastructure. So you can do that as well. But what I wanted to show next was that if I go back to this console here and do Terraform destroy, now obviously this is a destructive operation, so it's not in your production environment. You probably wouldn't want to do this necessarily, but I'm going to do it anyway. So Terraform destroy will tell you exactly what it's going to do. So it knows the current state of the VMs in the cloud, because it's kind of kept an eye on it as it was provisioning them. It will know that those are the things that have been created, and it will destroy them if we tell it to. So let's imagine I was able to make a connection over my RDP session, but what we're going to do now is we're going to destroy it. So what that's going to do, if we go back to AWS, where it was running happily, if we start refreshing this, then it's in the process of shutting down now. So that instance will then end up in a state which is terminated in the same way that it was before. Okay? Any questions? No? Okay. So to follow up on that, so that was us provisioning an AMI that we created into AWS. The next demo I want to take is that base box that we created, which was over here in demo 4. This base box, I want to now use that base box. I want to do something with it. So if I go to my shell and I do CLS, oh, I maybe shouldn't have done that. Let's have a new instance. And let's edit that session to make it bigger. Text 24 again. I maybe won't mess with the colors quite so much, because the white wasn't actually readable. So if I do Vagrant box list, so these are all the base images that I have on my machine. Okay? So if I wanted to provision, oh, it's already there, I didn't delete it. Vagrant box remove. Okay, so if I run that Vagrant box list again, these are the base images that I have. So that VMs that I spoke about before, that Stefan Scherer is responsible for, I already have them on my machine. So when I did that initial Vagrant up earlier at the start of the talk, I was using that base image that's already on my machine. So the provisioning of it via Vagrant is actually quite quick. Okay. What I want to do is I'm going to copy the command so I don't get it wrong. Over here. What I want to do is I want to run this command. So what we're doing here is we're taking that Windows 10 VirtualBox box, and we're going to add it into my Vagrant instances on this machine. I'm in the wrong folder. Where am I? Yeah. So it's going to take that box, and it's going to add it into my Vagrant instance. Then I'm allowed to provision another instance of that VM. So I'll already have Chocolatey installed, I'll already have Visual Studio Code installed, I'll already have Packer and Terraform installed. So rather than having to wait that 10, 15, 20 minutes, however long it takes, it should be very quick to spin up an instance of that. So while that's unpacking that, if we go back over here, what we spoke about in my first Vagrant file was that I had a base box of Stefan Shader Windows 10. So if I look at the second example, which is in this folder, I've now got a different base box. Yeah? So before, where I was at the bottom here, in this one, where I was doing all of these provisioning steps to install Chocolatey and install all those applications, on that second Vagrant file, I don't have any of that anymore, because all of those things are already there. So if that box is added, which it now is, I should, in theory, be able to go up to here, and then run Vagrant up. So I said before at the start, I didn't provision that box because it would take so long to do it. What I'm going to do now is, now I'm going to spin up this one because all of that stuff's already on it. It's at a known state, I've tested it, and it's got everything on it that I want it to. So what it's saying here is that the initial import of that base box has to happen. So what's happening there is that Vagrant is taking that base box and it's putting files on the file system so it knows where things are. So the first Vagrant up takes a little while. And by a little while, I mean maybe a minute. Okay? But once that initial import's done, doing another Vagrant up is really, really quick. Okay? So what I'm hopefully going to show you is that once this is finished, is I'm going to destroy that VM just with Vagrant destroy. And then I'm going to spin it up again, just because I can, and show you it being that much quicker. Okay? Hopefully that's not going to take, there we go. So 80, 90, and then it'll spin up the instance. So it'll probably jump over to, it'll come away from this session and we'll see the VM actually being created. Okay, so there's the VM being spun up. Let's just close this down. So there's Windows 10 firing up. And then all of those applications will already be there. Okay? So let's wait for Windows. It should log us in automatically. Okay, so Visual Studio Code's there, Chrome's there, all of the things that I said. Okay, so if I go back to here, once it's set the host name, it might actually do a reboot while that's waiting. Any questions while I'm waiting for that to happen? No? Anyone actually using Packer or Vagrant or Terraform? Liking it?
Does the job on Windows?
Absolutely. No. I mean, there are some interesting quirks. I found some interesting quirks with Vagrant. Sometimes Vagrant, a machine that spun up fine one time will fail the next time. It's normally due to networking. And a single VM instance, it normally always works. But as soon as you start using Vagrant to spin up multiple machines on the same network, then it sometimes get confused. So that VM's up and running, so I can do stuff with it if I wanted to. But I can go back to here. So that where that took maybe 3 or 4 minutes to complete that, if I do a Vagrant destroy, which will completely blow that machine away, so it's gone. If I do Vagrant up again, so rather than having to do that base box import, it doesn't have to do any of that anymore, so it just goes straight into the provisioning. So it's already booting the VM, and then it's up and running. So again, the immutable infrastructure side of things is we've got a machine now that we can give to someone that has all of me, say, all of my developer tools on it. So it's at a point that I can provision and give to someone. So it kind of breaks the whole immutable infrastructure a little bit in that scenario, because then that developer or that person is going to change that VM. But again, it's getting to a known state that they can then be immediately effective. So rather than on day one of their job, they have to figure out how to get all of these applications installed, where can they get them from, and do all this configuration, you could have all of that done up front with Packer, and then just say Vagrant up, and then they've got a machine instance that they can immediately start working on. And then if something goes wrong with it, they throw it away, and they spin up a new one, okay? So that's kind of the benefits of it, and that's it all running. So I've got one demo left I wanted to show, which kind of shows how to bring all that together. And the demo is called Bringing It All Together. There we go. Right. So imagine the scenario, if you like, where, and I've done this, and this is why I started looking into all of this. Imagine the scenario where you want to run a workshop for 40 people, and you want to show them how you can run Chocolatey, and to run Chocolatey and run all the commands on it. So we've done this before in the past, and the first attempt that we did at this was to use Vagrant by itself. So we had a base box that had everything on it, but we needed to get it onto their machines. So we needed to take a USB key had an 8 gig file on it and get that placed onto every single machine on in the classroom. Find out that that's really, really hard when one of the people who come to that workshop has a Windows Home Edition that's not allowed any sort of hypervisor installed on it, so you can't run that image. To people who have got lockdown machines where the USB keys are blocked, there's actually silicone injected into them, so you can't put a USB key into it. It's not a good scenario. Literally, on a full day workshop of trying to show how we can use Chocolatey, half of it was spent just trying to get people up and running and actually making them effective. So we moved away from that, and we started looking at how we can provision workshop instances in the cloud. So the way that we've done that in this repository, all the things that I've spoken about is what we're doing. So if we look at the Prepare VM section in Azure, then there is a Packer folder in here. And then in the same way that I had one before, I've got a Packer script that does all of that stuff, all of that provisioning, all of that setup, all of that installation and configuration work is done by Packer, okay? And then the end result of that is a base image that I can then provision multiple times for however many people are in the class, okay? So then I have a Terraform script. Now I say you'll notice his face appearing there. I have unashamedly stolen this from Stefan Scherer. Stefan Scherer over here does a similar thing for his Docker workshop, okay? So he has the same setup, and he wholeheartedly wants you to copy this, because he spent a lot of time setting it up, and he wants you to not have to go through that process all yourself, and instead just change the provisioning steps to make it do what you want it to do. So I have unashamedly stolen this from Stefan, and he was at the workshop that we did, and he was able to see it running, so it was great to see him actually in the workshop as well. So in this one, Terraform also going to be thrown into the mix. So we've got our Terraform files, which is doing the provisioning. And if we stitch all that together in another system, which is Circle CI, okay? So Circle CI is a continuous integration system, okay? So what this repository has in it is that every time I commit a change, it will rerun Packer, and it will regenerate that base image. Okay, so if I go over to this window and I look in this folder, then we'll see that there is a base image here called Windows 2016 610. 610 is the number of attempts I had to do to get this working, right? So literally every time it builds, it gives it a new incremental build number, okay? So there was a bit of back and forth making sure everything was working, and it's not quite as bad as that, and I'll explain why in a second. Each individual CI step is actually an incremental number. So there's multiple actual stages of the build process for this. So it's not quite as bad. I think there's 5 for every one commit, so it's not too bad. So anytime I do a commit into this repository, it will regenerate the Packer image, and it'll put it into my Azure account ready for usage. So then what I can do, if I go over to here, I can create a new release. So down here, you will see that when we were at the WinOps conference in London at the tail end of last year, we had 42 people in our workshop. So about 2 hours before the workshop started, I created this release, which then caused Terraform to go off to Azure, take that base image, and provision 42 instances of them ready to go. So what I'm going to attempt to do here, and I did one earlier today, about 4 hours ago, just to make sure that it did work. If I grab that, and the way that this works is if I draft a new release, and then let's just call it 29, then whatever number I put in here, it will create that many instances of that base image. So I'm not going to go nuts. I'm just going to do 2, okay? Let's just, because we'll be here too long waiting for it to finish. Because although in the same way that Packer works in parallel, so does Terraform. But there's limits on how many things it's allowed to provision at once. So when I did that 42, it actually provisioned a block of 10, and then another block of 10, and another block of 10. So if I go ahead and publish that release, then what we should see happening is we should see some build steps kick in. So these are steps along the lines of doing my Packer validate and my Terraform validate to make sure that what I'm trying to run actually works. So it'll actually fail the build if any of those things don't work or don't make sense. But what I'll actually start doing once this final step, which is PS Script Analyzer. So PS Script Analyzer is just being run on the PowerShell scripts to make sure that the PowerShell itself is valid. What it'll start doing is then it'll start doing the Terraform step. So this is where it'll actually start things into Azure for me. If I go back over to here and look at my resource groups, then it should have created a new one here, which is the test 29.2 resource group. And everything that Terraform is going to create is going to go into there. So it's already started, it started provisioning all the things that it needs. So the way that this thing's set up is that all of those workshop machines are on the same network, on the same VLAN, so they can all talk to each other. So it's doing all of those things. So it's going to create network cards, it's going to create IP addresses, it's going to create all of the bits and pieces that are needed to make that infrastructure work, okay? So if we go back to here, we'll see all of that happening in real time in the CI system. And the end result of that is I should have 2 machines provisioned ready for people to access. But then the question comes in, well, how do those people log into those machines? So we could make it such that the username and password is just hard-coded, and we could say it's just going to be Bob and Bob as the username and password. But the way that Stefan actually set this up, I can't claim any responsibility for this. The way that Stefan runs his workshop is on that machine instance, he actually kind of wants or needs them to actually put their Docker credentials into environment variables. So you don't necessarily want the person sitting next to you who you'd never met and you've only worked in that workshop with that day to be able to get onto your machine and steal your credentials. So what he's actually done, which is pretty cool, is that he uses, during the provisioning, he actually automatically generates a series of random passwords and uses them during the provisioning to actually say that this is going to be the administrator username and password for logging into that machine. And then what he has happen is he has it sent to a Slack channel. So you then get a PDF generated that contains all the username and passwords that are needed to connect to that machine. So prior to the workshop, you can then print that out and then hand them out to random people saying, this is your one, this is your one, this is your one. And the end result of that is a system that they can then use. So this is one that I created earlier, and hopefully the one will appear here as well. So we generated something with a username of training and a password, maybe hard to see, but there's a randomly generated password that you can use to log into that instance. So once that Terraform step is finished, which is here, so we're at the point of, we're at about 2 minutes 10. So it takes about 5 minutes to provision the VM and have it ready. So once that's finished, we'll then get a message in our Slack channel saying that here's a new PDF with the ability to log in to those machines. And we'll let that finish, and we'll take some questions if there are any. But that's kind of where I wanted to finish. So I just wanted to put this up. If you do have any questions and you're don't want to ask, that's all my contact details. So feel free to reach out on any of those mechanisms, and I will try and answer any questions that you might have. Are there any questions from anyone about anything we've spoken about today? Yes?
So it seems that the packages you have... yeah, Gary. So it seems that the packages you have there are all built around building VMs that are would have a GUI in, as opposed to, say, Docker.
Yep.
And all the Docker tool in Kubernetes, which would
Yep.
give you all headless machines. Okay. Because I've used all Docker and Docker Compose before.
Yep, but in the same way that I said before that Terraform has a provider model, Terraform also has a provider model for Docker. So if you wanted to spin up and have multiple instances of a specific Docker image running somewhere, then you can use Terraform to provision them as well. So it's not limited to a thick VM running somewhere. It's just that that's kind of easier to demo in terms of more applicable scenarios for certain people. So once we start talking about Docker, you have to start talking about lots of different scenarios. So the scenarios I'm trying to show here is that, like say, you are in a development house and you want to have a brand new VM that someone can spin up that's immediately available to start executing for them. You would use Packer to generate that base box and then have them provision it locally. Or you're in a workshop scenario where you're trying to provision multiple machines that people are actually going to utilize within that. But it can also be applicable. Once you start getting into Terraform, it can literally control lots and lots and lots of infrastructure. It's not limited to what I've shown here. It's just that this is kind of the easiest way to describe those scenarios, I think. Okay? Anything else? No? So maybe we'll jump back to here and see how we're getting on with our Terraform provisioning. So we're at about the 4-minute mark, so it should be very close to completing. What I will point out on my slide deck is the last one, which is there's a bunch of resources on the last slide, which is just on how to get started with Packer, Terraform, Vagrant, as well as Chocolatey, because like I say, it's Chocolatey that's doing all of the installations on that Windows boxes that I was provisioning. Obviously, that's not going to work. Chocolatey is limited to Windows ecosystem. It's not going to provision anything onto a Linux machine for you, but there are other package managers that will do that work for you. So over here, I was really hoping that this was going to finish before we draw it to a close. This was kind of my final hurrah. I wanted to show it working. Sure. Let's get the mic over.
I've also used Box Starter quite a bit for setting up dev machines.
Yep.
I find that quite useful because all the inbuilt things in Box Starter to pre-set up your package, you could fit that into this workflow as well.
You absolutely could. So for those of you who don't know, so Box Starter is built on top of Chocolatey. Where kind of Chocolatey stops and starts is as a package manager in the open source version. So once you start talking about handling reboots and additional configuration of a Windows machine, that's kind of where Box Starter picks up. So Box Starter can take a machine from a fresh instance all the way up to whatever you need it to be, and handling all of those reboots and provisioning. So absolutely, you could build that into this workflow as well. There's no reason you couldn't do that. Packer has some built-in things in terms of, so if you've just provisioned something that you know requires a reboot, then in your Packer JSON file, you can actually provision the thing that you know needs a reboot, and then your next one is immediately to do a restart, and then you can continue your provisioning steps. Something like Box Starter would handle that work for you. But absolutely, I mean, all of the configuration management systems can be plugged into this, what I've described here. So if you wanted to, one of your first Packer provisioning steps could be to install Puppet or Chef, and then have, or DSC, and then have those things do all the provisioning on the machines as well. So it kind of works in unison. It doesn't, using Packer or using Terraform doesn't stop you using any of the other configuration management systems that are out there to bring it up to a state of where it needs to be. So that's absolutely, you could absolutely use Box Starter in that scenario as well. It's taking ages. It's still going. Any other questions before? No. Okay.
So for the workshop, I take it everybody needs to be connected. So cost effective, how much roughly does that kind of...
So interesting question. So before the WinOps, so this is for running demos. I get a certain number of Azure credits through my MSDN subscription. So I was concerned, let's say, that spinning up 42 VMs and having them running for essentially the entire day, I was going to run out of those credits and all those machines were going to switch off and then it would all be horrible. So prior to the WinOps workshop that we did, I added my own credit card onto here so that if I did burn through my credits, it would be fine. They would continue running. But for the whole day, for 42 machines, I think it cost us £11.
Really?
And that was within the Azure credits that I had available to me. So there was no, we were still on the reasonably cheap side in terms of the VM sizes. It wasn't quite the T2 micro that we had, I showed you in AWS. It was kind of a middle of the road VM. But yeah, for the entire day for 42 machines, it was £11. So that's fine. So the time that we'd lost in the first version of the workshop that we did, which was taking that Vagrant box and trying to get it onto all those machines and get them all working and yada, 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 all of that kind of just goes away once you start utilizing the cloud. It does mean, though, you kind of need a fairly decent connection for all of those outgoing traffic and things that are going on, but RDP is relatively lightweight anyway in terms of a protocol, so it worked out quite well for us. So yeah, it was £11. It's still going.
Yeah, so you talked about provisioning VMs and things. It's similar to a question we already had, but we're working with like PaaS environment in Azure. Can you Terraform that? Because I know we use like ARM templates to do that. Can you do something similar with that?
Well, let's just have a look, shall we? Because I'm not going to lie. Provisioners, providers, cloud. Which one were you using, sorry?
Well, it's Azure PaaS, so we use like app service and that kind of
I'm fairly sure that the answer is yes, but I don't want to lie to you. Oh, major cloud, sorry, major cloud. I was in the wrong section. So what have you got in here? Does it list out what it can do? It does. App service plan, application
cool.
insights,
Yeah.
batch pool, client config, DNS zone, Kubernetes cluster. Yeah, I mean, I'm scrolling here. Yes
Yeah.
is the answer. You can
Great.
do pretty much everything. The flip side of that is if there's something it doesn't have, I think I'm right in saying that almost all of the provisions are open source. So if you had a specific requirement for some obscure thing that didn't have much people using it, then you could speak to the open source guys for HashiCorp and work with them to build that up as and when you needed it. But no, once you start looking at what is capable of, there's a myriad of stuff that you can get lost in. You really can. So last check. Oh, where did it go? Last check. If it's not there, oh, it's still running. Okay. There's no point in sitting waiting for it. It did. I showed you the Slack channel where the message popped up before. So that is from 3:21 this afternoon. I generated that PDF that had it in it. But that was a single VM that I did 2 this time, so it's taking slightly longer, which is unfortunate. But that's all I have. So
Cool.
thank you very much.
Well, there's no more questions. I think we'll